Hi, I'm John Galland. Welcome to this conversation about how photonics will help the world power its AI transformation. Right now, we're in an initial wave of excitement about how AI will change the world. But as we learn and do more, some tough questions are emerging. Among them are how to reduce network latency, manage vast data volumes, and meet the power demands of AI while progressing toward crucial sustainability targets. Photonics is a big part of the answer, effectively enabling next generation infrastructure that's optimized for a world where vast amounts of data will be processed at high speeds. This landmark, yet still relatively unknown technology, will be the focus of this CIO webcast brought to you with NTT. I'll be talking with Vito Mabrucco, Global Chief Marketing Officer at NTT. Now, before we start this discussion, Vito, let's find out a little bit more about you.
Thanks, John. Thanks for having me here today. My name is Vito Mabrucco, as a global CMO for the NTT Corporation. NTT Corporation being a $100 billion global technology leader. And we are in multiple markets around the world, as well as in our headquarter country of Japan.
Thanks, Vito. I know that you are deeply immersed in the area that we're talking about today. I'm really keen to get your insights on this for the audience. But let's start kind of at a high level. How do you see this dawning era of AI taking shape? I think everybody sees the transformative potential, but there's also some big questions that we have to contend with.
Yes, I mean, this is a very powerful technology, no doubt, and we're seeing, the waves of AI implementations that are happening. But, one of the concerns, of course, is that we've seen in the past where we have these new technologies, and the most recent example is social media technologies that were implemented without a lot of either regulation or self-regulation by the markets. And so we learned how important it is to, kind of look ahead and see what could the possible impacts be of this type of powerful technology. And we're doing that both as NTT, but also we're participating in a global initiative called the Hiroshima AI process. And it was launched at a G7 meeting in Hiroshima, Japan. The idea being that, we can't regulate everything. We have to get some cooperation and collaboration around the world. And now this particular process has lined up over 40 different countries who are working towards developing principles and code of conduct. And we ourselves as NTT have developed what we call the NTT Group AI Charter, which is kind of guiding us forward to ensure that it's going to be, fair, secure, private, and contributing both to people and society as well as to business results. So it's a very big focus area for us, and we are looking to take a leadership role in AI governance and ethics to make sure that we're doing the right things for the right benefits that we will get from AI.
Yeah, thanks for that, Vito. I know that NTT is taking a holistic look at this, not just the technology, but all those other issues you mentioned. But if we look at the technology for a moment, one of the key topics in this conversation is around photonics. So, will you talk about why photonics will play such a big role in powering that global AI transformation and deal with some of those issues that we talked about earlier around latency and data volumes, things that I hear from CIOs as real issues that they face?
Sure. I mean, AI is adding another layer of, complexity and volume of data and networking computing that we didn't fully anticipate. And yet we know that the current infrastructure that we have can't possibly support all of the new innovations that are going to result from the, very wide and broad and deep implementation of AI. However, one thing we also recognize is that we can't just do this with the current technologies. Typically, you can't solve tomorrow's problems with today's solutions. A good example of that is when the cellular network first came out. It was fine for phone calls, although barely. But once we started adding data to that infrastructure, we realized that the current infrastructure couldn't support it. Well, we are at that point now where if we keep adding the layers of AI that we're planning to do, the current infrastructure won't support it. So we're looking at another way of building out infrastructure that uses a different technology, which is photonics. Photonics being light-based transmission of data. And what that does is, of course, brings a lot of benefits, both regarding the sustainability of it, because it uses less power, but also the speed and the latency, as you mentioned, because latency is going to be very important. Latency meaning response time. So for those people who don't know, they look at latency as, when you hit the button on your phone and you think you've transmitted something and yet it's going around in circles. You're not getting the response time because it's hitting so many roadblocks. We want to take that latency out so that the applications of the future are going to be immediate. And that's the only way AI is going to work for people at the edge and for companies and all the different ways we're going to use AI. So that's why we believe that the infrastructure of the future will be based on photonics.
Well, let's talk a little bit more about that. There's an initiative of photonics-based infrastructure of the future that's outlined called IOWN, Innovative Optical and Wireless Network. Tell us more about how IOWN developed and why you see that as a really ideal choice to drive this AI transformation.
Yeah, IOWN was a concept that we actually first initiated in 2019. And at the time, our executives, our CEO, our CTO, and several other executives actually wrote a book called IOWN, The Next Internet. And the idea is that we already saw back in 2019 this massive amount of data and compute coming at us. And we predicted that the infrastructure, both networking and computing, couldn't support that because we saw the volumes going. And just like I said, you can't expect today's infrastructure to support tomorrow's needs. Then that was 2019 before AI was even much of a discussion. Then we layer on AI, which adds another 20-30% capacity and networking requirements. And we recognize that we definitely need to move towards a new infrastructure. And so what we think about is photonics is addressing what I call the supply side of the power equation. So today's discussion is all about electric grids and building more nuclear plants and generating more power to support all of this data infrastructure. And we're going to need to do that. But our approach is to reduce the amount of power needed to generate the same kind of output. So you're addressing the supply side, if you will, of the power energy needed by lowering the amount of power for the same amount or greater output. And if we can do that, we can do that at the data center, we can do it at the server side, and we have some plans to how we can do that at the board level and chip level, because ultimately we're going to have this infrastructure discussion, not just for networks, but all the way down to the devices that are going to have to be powered with AI.
So let's take a couple minutes to look at some IOWN use cases. One really interesting area is what's called disaggregated computing. So I'd love if you tell us more about what that involves, and in particular, how you see that boosting sustainability, which we know is an increasingly important factor for IT teams in their operations and in their purchase process.
Yes, this is an amazing opportunity for us to change the paradigm of computing. Because as many people know, a computer system is built with a CPU and then multiple other XPUs, whether it's a GPU or storage or networking. And it's all kind of connected into one single server, and then we connect multiple servers. The problem with that, of course, is that we're not maximizing the capacity of all the different computing capabilities of that computer. And the reason is because we're connecting all of those components using an electronic bus, or PCI bus as it's called. By using we have to use electronics because of the speed and the connection of those devices. What we are moving towards and have some patents on and are developing the technology for is replacing those electronic bus connections with photonics. Now, when you start to do that, you realize that you can implement inside a computer this idea that you can connect all the different pieces using photonics, which will reduce the need for them to be closer together. And what we think about is taking the GPU and the CPU and the storage and separating them and connecting them with this optical bus, which gives you the opportunity to treat each of those kind of processing units as pools of processing units. Now you're getting more capacity and more efficiency out of those processing units. It's a very strong use case for us. In fact, we're doing a test now where we are putting GPUs into a data center separate from where the data is stored, so that you can do GPU, you can do LLM, processing and learning in one data center while keeping the data stored in another data center. And the GPU doesn't know that it's in a different data center.
And that's incredible. So, Vito, one of the areas when I look at different vertical industries, banking seems to be a sector where this technology could have a powerful influence. Can you talk us through what work you've done here and what you think the potential is?
Yeah, banks are, of course, one of the most technology intensive industries in the world. And they are one of the most important industries in the world. They protect our money, corporate money, they manage global governance. They're really the backbone of our society's ability to function. So there's a few things we need to think about around banking. One is how to make sure that we can recover from any disaster, both natural and human, because there's a risk always of cybersecurity attacks. So how do we make sure that those systems are more resilient and able to recover? And so to do that, we again think about photonics as a backbone that is faster, more resilient, and more flexible than what we have in the current infrastructure. And with an all photonics network, you would have near instant recovery of transactions, which today you're losing in stream or losing, throughout the internet, which gets hops of data. We're talking about direct connection of all photonics from one data center to another. And this actually, we are starting to think about this beyond just banking, which is obviously one of the most important, but what about the idea of backing up a country? So we have connected, for example, Taiwan and Japan using this all photonics network, so that if there is a natural or unnatural disaster, you basically can back up the banking and the records, because you need to protect all the records as well. So it's one of those things that the industry's always talked about, but we've never really thought about how we can implement photonics, not just to transmit data, because the one point I wanted to make is that some people would say, well, photonics, fiber optics has been here forever. But that's true. We actually are, we laid fiber optics cable undersea for the last 30, 40 years. The difference is that we're adding intelligence to this now, and we're taking it from simple transmission to actual computing and networking to ensure security, privacy, speed, and low latency. So it's a very different use, if you will, of an old concept applied in a new way.
Vito, can you talk a little bit more about that intelligence? What do you mean by adding intelligence to it?
Well, in order to create this idea, even for example, when I talked about the disaggregated computing, we have what's called the photonics electronics convergence chip. And this convergence chip has to be able to convert from electronics to photonics. So inside there's an amount of processing, if you will, inside that electronics device to take it from electronics to photonics. And you can't do that just as a pass-through. You have to do some work in that calculations to make sure that the data is being transmitted. Because, what we're not suggesting that we're going to change all of the operating system requirements and all of the systems requirements, because that would be impossible to do. People don't want to make that level of investment. So we want to take what already exists and make sure that we can implement photonics or fiber optic connections at a very miniature level. So whether it's boards or chips or even inside chipsets, that requires a certain amount of IP and investment. We're investing billions of dollars a year in this technology, and we know and believe that it's got some very long-term potential.
Yeah, it sounds so promising. So, Vito, are there other use cases that you would highlight? We talked about disaggregated computing, the banking industry. I'm thinking things like video and robotics. Robotics are among the scenarios that could benefit from that. But what other kinds of applications would really benefit from this photonics technology?
Yeah, there's a couple. Actually, robotics is a good example. It's a hot topic, but typically robotics today is stationary and rote, and they're kind of like doing the same thing over and over again. And if we really want to get to the point where robotics are more human-like and making human-like decisions, then we're going to need to move AI to the edge, the robot, a robot being at the edge. And we know that in order to do that, we can't use the existing technologies because of the power requirements and the processing requirements. So, in a factory floor, for example, or a dangerous processing plant, if you want to use robots to go out and do maintenance on a very dangerous site, you're going to need to have the ability to have AI at the edge, AI at the core, and all the networking in between to make sure that it's almost, in fact, instantaneous. And if you can start to do that, you can see all kinds of new applications, whether it's on the factory floor or whether it's in the operating room or whether it's in on a construction site or mining. The future of robotics is really dependent on an infrastructure that's going to be able to have AI from the edge all the way to the core. And again, power consumption, speed, latency, those are all requirements. And you can't get there with electronics. You just can't. We have to have a new paradigm of how we're going to do computing because today's paradigm of electronics has hit a wall. Just think of your phone, right? Your phone has hit a wall. It's only got so much battery power. It can't do anything more. And in order to make that phone, in fact, there are discussions about, the phone of the future won't be what we see today. It will be a completely different device. It'll be an appless device. It'll have much higher power at the edge to do the kind of work that you want, which, I can't even imagine yet, but we know that that's kind of where we're going to go eventually.
I'm fascinated with this discussion of the edge because it comes up a lot, and it always seems like an area that's constantly in flux, and that the plans for the edge, people are still uncertain about the plans. But when I think about so much analytics, AI, digital twins, things like that, that need to be done closer to the sources of information, this seems like it has the real power to accelerate the deployments at the edge, really make this edge a critical part of the whole overall compute infrastructure.
Yeah. Well, I mean, the edge, we don't always call it the edge. You and I, our industry calls it the edge, but really it's everything around us, right? It's our cars, it's our homes, it's our lights, it's everything around us is at the edge. And cars, autonomous cars, trucks, and vehicles, how are they going to operate unless they have significant power at the sensor level for them to read and act immediately? Yeah, you can have it networks, and we're going to have better networks and always, continually have better. But you want these things talking to each other at the edge. There's not enough time to start to transmit and come back and make a decision to turn right or to avoid that pedestrian. So in order to do that, we're going to need very low power usage, high capacity sensors, computing, chips, all that kind of stuff. And, there's a lot of algorithms that are being built, and, photonics is not the only answer, but we know that as a component, it's going to have to lead to that idea that you need to use less power to generate more capacity in order to make this work. And that's, where we think where the world is going.
So looking at this from the perspective of a CIO, I think this is wonderful. This sounds really promising. I can understand how it has this transformative potential, but I also think this is going to involve a huge amount of collaboration across the entire tech industry. How do you see this actually taking shape?
Well, that's a very good point. And we, luckily, or maybe just by design, we are a huge believer in open collaboration. And, you and I have been in the industry long enough to see companies who, try to go it alone, and it looks good for a while, but it doesn't become ubiquitous and it kind of stays as a little niche. What we did instead was we decided that we were going to reach out to all the leading technology organizations in the world. And we created an organization called the IOWN Global Forum. And it was founded by NTT, Sony, and Intel. And now we have over 150 leading global organizations involved in it, everything from telcos like Orange and BT. We have networking companies, Ericsson and Nokia, Intel, Qualcomm, Broadcom, NVIDIA, Dell, Accenture, Microsoft, Google. I mean, they're all there. And the reason they're there is because they want to be able to get in on the first development of the use cases. So the IOWN Global Forum, the main focus there is to develop technical use cases, not, high end. Yeah, we think it's going to do this. Technical use case, like the financial one I was mentioning earlier. We're actually doing that with MUFG, which is a very large banking company in Japan, and they helped us develop the technical specs that were required for their network, and that's a real application of these companies coming together to develop a real solution that then they can take to a proof of concept and ultimately to develop standards around the world. So having this very large group of companies come together, developing use cases and leading towards technical standards is how we think is the long-term way to solve this problem. And, some companies would say, well, that means you're giving up some of your ability to, capture the market. And our view is that we'd rather have a smaller piece of a very large market than, a large piece of a small market, because of the risk that small market may go away.
It makes sense. So I would also ask, from a CIO perspective, I'm a CIO. What can I do to get involved with this in this new chapter of digital transformation? Is there a role for me? Should I be studying something? Should I be asking certain questions? What's your advice to CIOs? How can this shape their future?
Yeah, I mean, we would love to get CIOs joining the IOWN Global Forum. We already have a few, but those are the people who really have a pulse of what the needs are. So they're welcome to join the IOWN Global Forum. It's at iownglobalforum.org, or maybe visit one of our events. We have multiple events around the world. Or they can reach out to anybody they might know at NTT or NTT Data, which is one of our big operating companies in the global market. They could go to global.ntt to learn more about us as well. So I think there's lots we can do. And CIOs, to be fair, I think that's where we need to reach out more to bring that kind of knowledge into the IOWN Global Forum, because they're really the ones who know where the problems are, and that can help us develop the solutions for the future.
Yeah, that's good advice. I mean, it sounds like probably on that site there's great resources explaining the initiative, the current use cases,
Right.
so at the
Use
very
cases,
least,
yep.
to review that and see what work has already been done.
Yeah, that would be great.
Makes sense. So, Vito, as we come to the end of this webinar, how would you sum up the potential of photonics? What are your key takeaways for the people who've been listening to this?
I think the key takeaway is that the future of the internet is going to have to change to meet the demands of the AI, that's about to wash over us. And we can't expect to deliver tomorrow's solutions based on yesterday's, infrastructure. So the transition to a more photonics-based networking and computing solution, we believe, is a key component to the future of the industry. Now, the challenge is the pace and adoption rate. Like you've seen in the past, the greatest ideas don't always make it over that hump or over that chasm. So we're really looking to, engage more people to help develop the types of solutions that they need, so that the adoption rates can exceed, or accelerate, if you will, to address those challenges of sustainability, security, and the next internet that will be based extensively on photonics.
That's great, Vito. I knew that you would have the deep insight on this that really benefits people. This is the end of our CIO webcast with NTT on how the world will power AI transformation through photonics. Vito, thank you so much for sharing those insights. And thanks to everyone who watched. It's a pleasure to have you. For CIO, I'm John Gallant.